Hello everyone, my name is Anthony Bui. This is my oral presentation for exam 3 part 3. So before I answer the question why scientists using the pattern of the agarose gel as shown in the picture on the right side up on the DNA fragmentation, I will first take you guys to the introduction of what is the package of DNA in nucleosome, chromatin, and chromosome. So the first step, as you guys see as showing pointing to the orange arrows, the nucleosome is the basic unit of chromatin structure, also known as DNA. It bursts through the nucleus. And the histone is the basic protein that forms the core of the nucleosome by binding to DNA. We have each nucleosome consists of 8 histone molecules, which are 2 of the H2A, H2B, H3, and H4 associated with 146 base pair of DNA. Second step, you can see on the orange arrows, we see that histone H2 is binding to the linker of DNA. The linker DNA is a 50 base pair of DNA double helix that start packing nucleosome to the 30 nanometer chromatin fibers. Therefore, we have the DNA is fragmented in multiple rounds of 200 base pairs. The third step, and as the arrows pointing at, we have those 30 nanometer chromatin fibers folded into the 30 nanometer chromatin fiber of the DNA loop. And the fourth step, we have further folding and coiling of the loop to be more complicated and more condensed and of the folded chromatin, which we call the heterochromatin. So this heterochromatin turns into the duplicated chromosome with highly condensed DNA. And this duplicated chromosome is attached by 2 chromatids and from the dividing cells. I will go back and talk about the agarose gel later, but first before I finish my slide 3. So what's apoptosis? Apoptosis is the death of cell, which is normal under the control for cell development. So in this question of part 3, the scientists using 2 micromolar of camptothecin to trigger the apoptosis of the Churkat cell. Churkat cell is the human T lymphocytes at different hours, which is 0, 6, and 12 hours. So the step of apoptosis, as you guys can see, I put on the top right pictures from the textbook. We have during the early phase of apoptosis, the DNA segregates near the periphery of the nucleus. That's why the nucleus, cytoplasm, and a couple of organelles begin to fragment. And then the second step, we have a DNA is cleaved by DNA endonuclease, or DNase, which is the enzyme that digests the DNA. And the result that we have 200 base pair of DNA fragmented into small pieces called apoptotic bodies, which are remnant of dead cells. So the last step is that because of that inactivation of lipase, we have the phospholipid translocating result in the accumulation of phosphatidylserine in the plasma membrane and give signal for the phagocytosis of cells, such as the macrophages, for injection, which is feeded those dead body cells. So talk about what triggers the apoptosis. First, this is one of the hallmark of apoptosis, which is indirectly being affected by removing survival factors that can trigger apoptosis. So the first step, if you guys notice on the picture I put on the bottom right, only focus on the bottom part because the number from 1, 2, 3, 8 is that's a different hallmark. So the hallmark I'm going to talk to right here is only 4, 5, 6, 7, 8, and 9. So when we remove the survival factor, we have the death promoting protein that fight against anti-apoptotic proteins such as BCL2 in mitochondrial membrane. BCL2 is a inhibited apoptotic protein factor. So seeing that result in the death promoting protein, it will release cytochrome C. Cytochrome C is the protein that has to trigger apoptosis when released from mitochondria. So cytochrome C form a complex with other protein and activate the initiator caspase 9. So the initiator caspase 9 will activate the executioner caspase 3 to trigger the apoptosis, which is the key initiator of apoptosis. This is just an example I use in the textbook because it's related to a different kind of T lymphocyte, which also kind of similar to the Churkat cell T lymphocyte. So go back to the agarose gel I show over here. The reason why they use this pattern DNA fragmentation to show you guys how all of those structures, chromatin fibers, chromosome, nucleosome, and linker DNA all fragmented out after we apply the camptothecin into the Churkat cells. And you guys can see that actually, and the result in the 200 base pair of the fragment DNA of the apoptotic cell body fragment, dead cells. As a result, we see that LAM3 actually has a little bit different of the intensity than LAM2 and 1 because it actually been actually with the camptothecin longer amount of time. So another, for the second question, I would like to address for the different biochemical pathway of apoptosis is the FAST pathway. FAST stands for first apoptosis signals, or C9 CD95, which are the protein belong to the tumor necrosis factors, receptor subfamily. So this is the the recent article I found on NCBA. They demonstrate how the FAST pathway can be cooperated with the BCL2 pathway, and that will turn to apoptosis. So the interaction between FAST and FAST-L, which is FAST-L stands for FAST ligand, results in death inducing signal complex, CISC, associated with the FADD, mediated activation of cascade 8, as you guys see on the arrow as shown over there. Activation of cascade 8 result in activation of cascade 3 and 7, which lead to the cleavage of vital protein with the cell. So you guys see on the left, we have a different mechanism of the BCL2 regular pathway, induce the mitochondrial outer membrane permeabilization, MOPP, to release the cytosol from C, from mitochondria, into the cytosol and initiate the cascade 9, and communicate with cascade 3 and cascade 7 from the FAST pathway on the right side. And together, they all have to trigger apoptosis. I put the reference to the article at the bottom. The second biochemical hallmark of apoptosis is a p53 pathway, similar to the example they give in the textbook. When the cell are unable to repair damage itself, such as exposure to radiation or UV light, it can indirectly trigger the mitochondrial pathway to apoptosis by the activity of p53. This is also the article I found on NCBI website, and as well as the picture, I put the reference at the bottom. So the p53 mechanism works with the protein PUMA. PUMA is the p53 unregulated modulator of apoptosis. It has to induce apoptosis by blocking the function of apoptotic inhibitor BCL2. So the fat arrows that I'm pointing out over there, the fat black arrow is illustrate how p53 induced target that trigger apoptosis, and a thin arrow illustrate p53 induced targets that are associated with the BCL2 regular pathway. And the broken arrow show us that not only the PUMA protein are associated with p53, but also another protein indirectly being activated, which is the BIM, which is a protein in human encoded by the BCL211 gene. And altogether, they activate the cytochrome C to release and then activate the cascade 9, as you can see towards the end of the picture. Only focus on the top picture, okay, not at the bottom. And then when activated, cascade 9 activated, they lead to cell demolition.